Hi, this is Jeff from the Ozark Mountains, that's in Missouri, in the USA. Well, today we're going to start restoring this TRS-80 Model 4P. This is a more compact Model 4. It actually had a carrying handle and everything, and for a portable of the day, it's really not too big and bulky and heavy. Of course, this doesn't work. It's nice and yellow, a little beat up, but we'll see if we can't get it working. In the front cover here, I've got a new modern power supply and some bits and bobs that came off it already. So we'll go ahead and tear this down and have a look inside. I know already that it doesn't work, so I'm not going to bother powering it up right now. It hasn't magically started working in the last 9 months since I've had it, so let's dig in and see what we can find. Thanks to PCBWay for sponsoring this video. They do circuit boards of all sizes, small circuit boards, medium circuit boards. They can even assemble them for you. Head on over to PCBWay.com and check out their 8th anniversary promotion. They have coupons, a sale, and even a drawing. Be sure to take note of all the services they offer: circuit boards, flex boards, 3D printing, even CNC machining at PCBWay.com. Because of the size of this thing, I've got the camera a little further away. That way we can get everything in the shot. And these screws are out of the side right here. So I'm going to go ahead and tilt this guy on its face. And yeah, I think we can go ahead and slide this back plastic part off. Like so. Hey, a genuine bug fell out. Nifty. See, the keyboard tucks into this slot underneath. It's got a cable tie here and a plug there. Okay. So we'll cut it as far back as we can. There we go. Okay. Well, I think we're going to have to wait till we can start sliding the main board out before we can get to that plug. So maybe for now, we'll just set this guy over to the side. Got some type of rubber material there. This is a stop for the keyboard, it looks like. There are some screws on this back panel. I've got one black one in this black plate and a couple silver ones here. Okay, these are the screws out of the silver plate. Little screw out of the back plate. There's a couple other screws over this is like a port cover here. I'm going to go ahead and remove those too. Might make it easier to clean everything up later. Okay, yep, on the cartridge connector, it's got a little plastic deal in there. And I've got a little plastic plate here. Okay, this is a support for the handle, the carrying handle. That's got a couple other screws on the side here. There is a service manual online for this thing, which I will put a link to in the description. Okay, and these are like the other two screws from this cadmium colored bracket that's on the back here. That's the handle support. Oh, there's 3 other little black screws at the top here. It's interesting, they only bothered black powder coating the bottom half of this bracket. Guess that's all that was going to be visible, so that is all they did. Okay, 3 little black screws, and that comes off of there. Now we can kind of see the inner workings of this thing. And yeah, we've got the disk drive wasn't plugged in, but that wouldn't stop it from working. It's got the slot in here for the internal modem. And this is the power supply deal. As I recall, yeah, it's got kind of this tray that the motherboard sits in here on the bottom. But the tricky bit is down in this corner. I'll get the camera over here so you can see. There are some plugs which go up to the innards. And this is where we can get to the keyboard plug. So I guess the question comes down to the best way to go from here. Maybe take the front bezel off. Just straighten the frame out here. Yep, there's another bug. Some bugs from Ohio. I'm going to go ahead and unplug the keyboard. And first I'm going to take a picture of how it's plugged in there. Now I think we'll try to take the front off of this guy. Now, they go through kind of a angle bracket here, which is what the plastic cover bolts to. And we've got another one of these brackets over on this side. And see what else is on the front here holding things together. Yep, just like an old TV set, the knobs have to pop off the front. Okay, it looks like some stuff from the front is kind of connected in with this drive bay, maybe. Yeah, it definitely feels solidly fixed here, and I see a couple other mounting posts down in here on this edge of this part. So I think I should take this cover off. Some little black screws. So 4 screws along the top here. And these screws are already out here. Yeah. Well, that was nice of them to hide a couple screws on the bottom, where you almost can't get to them. Goodness gracious. So there was 2 different length screws in that. The rearmost one was shorter. Yeah, the rear one was about 6 millimeters long. And the front one was closer to 9 millimeters. Okay, now does this guy come off of here? Oh yeah, look at that. Now we've got our drive bay off of there. You can see we've got a slightly disconnected cable there. So this one had the original 5 1/4 drive, and somebody retrofitted a 3.5 inch drive into it. I still see a couple mounting posts right here, which, yep, and I can see some big screws. But there's got to be more of this frame that comes apart to get to those big screws. So one thing we can do, maybe to ease access is open up this top. The power supply is actually mounted on the bottom of the top, if that makes sense. There's some more of those little black screws that are about 8 or 9 millimeters long. So what I'm hoping is we can get this all apart and clean up the plastic case material. And kind of sprawl it out on the desktop and reconnect it to work on it. Okay. Rotate this around. Take some pictures, always a good idea, of how everything is plugged in. Okay, there are 3 plugs on this guy. Okay, there we go. Now I have a replacement for this. These are known to be problematics. The solder joints along the plugs tend to crack, and it has some problems with the 12 volts that goes out to the video driver circuitry, pulsating somewhat, and the new power supply has a separate 12 volt power supply for that. I went ahead and picked that up at the Tandy Assembly Show last year. I thought it was a pretty slick idea. And yeah, so now here and here are the other 2 screws we have to get to take the front off of this. Now you notice I've been careful. I'm not touching around here. This is the high voltage section, or up here around the tube. You get all these really dire warnings on YouTube and the internet in general about, oh my God, CRTs will kill you, and your hair will fall out and you'll be impotent or whatever. Yeah, you can get a good shock. The most dangerous thing is your reaction to that shock. There's not enough energy here to kill you unless you have some really serious heart condition. So yes, you should be careful. Watch what you're doing. Realize that this can remain charged up for, days or weeks or months afterwards. We need to discharge it when we work in this area. Don't be scared to death of it. That's just going to make you make more mistakes. Yeah, be respectful. Don't be terrified. Being terrified isn't going to do you any good. Think of it like, getting a really bad static shock from walking across the carpet or touching the spark plug on a lawnmower. It's that type of thing. It's a high voltage. You're going to get a good shock from it. It might make you jerk. There's not enough energy there to do serious harm. This thing hasn't been powered on in 9 months, but I'm going to play it safe here. I'm going to go to a chassis ground and slip underneath the anode cap. Make sure I touch that metal part underneath there, and keep my screwdriver on there for a long period of time. If it's charged up, a lot of times you'll hear a snap as you're discharging it. We didn't hear a snap here, so it was okay. But that's the best thing to do, just so you're not surprised later. And okay. Longer screwdriver. Let's see how we get along with him. Yeah, that's better. I think it's loose. Okay. These are the same as the other screws on the outside. And our front panel came off. Other than being, you know, a little yellowed and dirty, it's in pretty good shape. Slight crack on one of these ears. That's about it. So I'm kind of happy with that. Okay. Oh, even more bugs in there. Oh my goodness. And here is the front of it. We've got our CRT, more bugs. Those look like stink bugs. And these plugs here, which are really difficult to get to. See if I can zoom you in on those a little better. Yeah, these plugs here connect the main board to the rest of the frame. And without tearing it all apart like this, they're kind of hard to get to. You've got to rotate this motherboard tray down enough to get your fingers in there to unplug those. Saw somebody do it. It's not the easiest thing in the world to do. So what I'm going to do now is unplug these plugs, separate the motherboard tray, this from the CRT frame, this guy, and take everything out to the garage and get all these bugs and dirt and things out of it with the air compressor. And then we'll see if we can figure out how to set this up on the bench for some testing. Before trying to power this thing up with the new power supply, I want to make sure that there are no short circuits, nothing apparently wrong. This black and purple wire right here runs over to the video board on this side of the frame. And if we ohm this out, get about, if you can see that with a reflection on there, about 17 ohms at 12 volts. That's, you know, 7/10 of an amp. It's probably okay. And I found on the schematic the pinout for the power connector here. We have ground here and 5 volts. Yeah, 1.4K, that's fine. 12 volts. 5 meg, 12 meg, that's 12 plus 12 and minus 12. I imagine the 12 volts that's going into here, I'm not sure where that would have gone to. This has 4164 DRAMs. It doesn't have the older DRAMs that take 3 supply rails. So, well, the plus and minus 12 is probably going to the RS-232 circuitry, come to think about it. At any rate, I think we're in good shape to try to power this up with the new power supply. So the next order of business will be to put the new power supply in. So here we have our original power supply mounted on the inner top cover. Here's our replacement power supply. It's made to set in exactly the same footprint. It has the same connectors. And now the guy that made this has one that works in both the 4 and 4P. So you can buy one power supply and use it in anything. These use off-the-shelf Meanwhile power supply units, so if one of these happens to go bad, it's easy to replace. And installing it is just a matter of taking out 4 screws. And we can leave the insulator sheet in there. Just for fun, we can have a quick look at this power supply. There's nothing visibly bad. I don't see any bulged caps. One common issue with these is cracked solder joints. And these are looking rather sketchy right here. I don't know if I can get the camera focused on that good enough. Yeah, all three of these, which are going to ground, are cracked. Those look okay. And our AC input here, that looks okay. And a lot of times on these older supplies, you also have to look at the joints on all the big heavy parts. But I don't have to worry about that since we got a new power supply in there. Now we'll get all of this kind of arranged so we can plug it in and see what happens. Yeah, like this. Video 12 volts there, and power in like that. And I'll confirm this with the photos I took ahead of time. And then this just mounts here just like the original. Okay, it is just possible to get the CRT kind of arranged here, the power supply installed, all the connectors plugged into the main board. I am going to plug this into the wall now, and we'll try to turn it on and see what happens. At least in this position, we should be able to check for some voltages and that type of thing, and get an idea if the main board's running, if we have a display driver problem, that sort of thing. Okay, try turning the power on. The fan's going. We have some, oh my goodness, look at that. Our screen is way too bright here. It says the floppy drive is not available. Diskette Laufwerk ist nicht im System. So the disk is not in the system. I think that's German. And Unit disk suppel absent du system. There's no disk in the system. I think that's French. Wow, that was rather anticlimactic. A lot of work getting it apart, and popped in a new power supply and got this all arranged, and it comes up. Now this doesn't mean everything's working. We need to look at our disk drives. We need to do all the cleanup on the case. We need to test everything. Need a boot disk. So a lot more to do. Let's keep going. After doing some reading, I found out that there is a RAM test built into the Model 4P ROM. And so I hooked up the keyboard. And to launch the RAM test, we hold down the period key on the keyboard to turn it on. It says enter to begin test, reset to exit. Any errors detected will be displayed. Now this isn't using the operating system. It's just testing the RAM and writing directly to the screen RAM. So we're not going to have like scrolling and things like that operating. So we'll hit enter. And it tests for a few seconds and it starts popping up errors at address 9401, which is a hex address. And it seems like there's errors all the way down to FFFF. So now since we don't have screen scrolling, all the new errors are just going to be displayed on this bottom line. And I noticed to start with that it said it was writing a 5.5 and it read a D5. And it was like that for all these addresses. I'm like, well, bit 7 stuck. So I got out my period correct Radio Shack Logic Pro, which I bought in like 1984. And I thought, well, we'll check the output of bit 7, which is this IC right here, U140. And the output is pin 14 and pin 2. They're tied together. But as you can see, I've got this set in pulse mode, and it's telling me there's pulses, which means that that bit is indeed changing. Well, that's kind of odd, isn't it? It's not stuck. And then I noticed I was taking so long with my logic probe testing things that as the test progressed, it's testing with different bit mask, and it seemed like that bit 7 was inverted. It's writing an 8 seed and it's reading a 0 seed. And I thought, well, how is it that bit 7 and only bit 7 can be inverted? Maybe that's some strange failure in the RAM chip. I haven't seen that before. It seemed kind of odd. And then I got to thinking about it last night that the first address that fails is 9401. If it was a problem with bit 7 in general in the RAM, we would see that starting at address 4000 where it starts. So that kind of limits the possibilities down to the RAM chip for bit 7, which is right here, bit 0 being right here. And since these are socketed, the easy thing to do is just swap two chips. We'll swap bit 0 and bit 7 and then see if we have a problem with bit 0 starting at address 9401. Let's do that. Okay, I've swapped bits 0 and 7 and hold down period on the keyboard, turn it back on, and press enter. And 9401, yep, see it's changed. If you can read that on the screen, it might be a little small. Maybe I can zoom in here. It wrote AA and it read back AB, so bit 0 is now off. So we have a bad RAM chip. That wasn't too difficult at all. Now you might say, well, okay, but you could have just swapped RAM chips and that would have been easy anyhow. But if they're soldered in, it's worth taking some time to think about it and consider all the possibilities before taking the risk of desoldering a chip and maybe messing up the board. So now I'm going to turn this off again. We'll grab another RAM chip and pop in there and we'll rerun this test. Okay, got a new RAM chip installed. Let's try it out. So the new chip is installed in the bit 0 position. And well, it seems to be taking longer this time. And I'm guessing it's not finding a problem. I don't know how well this is coming out on video. It might be a little blurred, but it's trying all the different mask values now and writing to the entire 48K of RAM from 4000 to FFFF, and it hasn't found an error so far. That's good. So I'll let this run for a little while. Note this is not testing the entire 64K, and this thing has another set of sockets here, so you can go up to 128K. Once we get this to boot up and make sure everything else is okay, we can go ahead and populate that with another 64K. And somebody on the TRS-80 Discord channel sent me a good memory test program, so we'll try that out. Now we need to clean up that 5 1/4 inch drive so we can try to boot this guy up. Well, this seemed like a good place to take a break. We got our old 4P disassembled, we got all the stink bugs out of there, swapped in a new power supply, found a bad RAM chip, and fixed that. Just being able to run and pass that RAM test let us know that the major part of this 4P is working. We've got a good video display, our processor and support circuitry and all that is running, so we're in good shape. Now in the next video, we'll move on to cleaning up that 5 1/4 inch disk drive and figuring out how to make a boot floppy and get this thing booted up. So hope to see you in the next video. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means. It's greatly appreciated. You help keep this channel going. If you have any questions or comments, well, you know what to do. Just leave them in that comment section down there below. I would love to hear from you. The things I've talked about in this video, I'll put links to those in the description down below. Well, until next time, bye.